Guys, good afternoon. My name is Einstein Milan. I'm a software architect here at Whiteprompt. And today I'll be talking about Kinesis for big data. And just wanted to give some information about our Tech Talks. It's something that's done every week. And we just do a little research and we present things that we think are worth sharing with the rest of the company, and where we talk about challenges, technologies, and anything else that may be worth sharing. So just you can go to our YouTube channel and hit that subscribe button, like our videos, help us get the visibility out there. So Kinesis for big data. Kinesis is a platform on AWS that's used to send data to. It makes it easy to load, analyze streaming data, and also provides the ability to build your own custom applications for your business needs. Let's give a little bit of definition. What is data streaming? Data streaming is the process of transmitting continuous flow of data, also known as streams, typically fed into stream processing software to deliver valuable insights and data. A data stream consists of a series of data elements ordered in time. The data represents an event or a change in state that has occurred in the business and is useful for the business to know about and analyze, and often it's done in real time. Some examples of data streams producers would be sensor data, activity logs, IoT devices, financial transaction logs, and browsers. A data stream can be visualized as an endless conveyor belt carrying data elements and continuously feeding them into data processors. AWS has a Kinesis, but it has 3 different services that Kinesis entails. One of them is Kinesis Data Streams, the other one is Kinesis Firehose, and the other is Kinesis Analytics. And they all have different applications and use cases. So just wanted to give a brief visualization of how this thing kind of works. We have IoT producers. As mentioned before, it can be a mobile phone. It can even be an EC2 instance, a laptop, sensors, anything that continuously pumps data and that we can analyze and run in real time. So the keyword for Kinesis streams is real time. And by the way, guys, feel free to jump in. You don't have to wait till I'm done. You can jump in and ask questions at any time, because I know a lot of questions are asked, and you may forget some at the end. So this is an open discussion. You can stop me at any time. When these things are produced, or this data is generated by the IoT devices, it goes into the Kinesis streams in the shape of shards, in the form of shards. And a shard contains information that is produced in the form of a blob. It can be a string. It can be any data you want to send through the Kinesis stream. And the way it's output to the consumers, which can be EC2 instances, it can be Lambda functions, it can be many things, which are not depicted in this picture, unfortunately. It's in the form of base 64 string. And then you can decode that. If it's an image, we all know that we can turn base 64 strings into images, blobs, or anything else. So we can manipulate that data and then land it for feature analysis or for storage, be it a DynamoDB instance, Redshift, buckets, or even an EMR cluster. So as I was saying before, Kinesis streams consist of shards, and here are some of the technical specs. You can do a max of 5 transactions per second for reads, a maximum total data read rate of 2 megabytes per second, a write rate of 1 megabyte per second. As you can see, the next bullet point, 1,000 records per second for writes. And the data capacity of your stream is a function of the number of shards that you specify. So when you set this up, this doesn't scale on its own. You have to kind of know what your traffic's going to look like and how fast you want to pump information through the system. you can specify the number of shards the stream can contain. So increasing the number of shards, you can put more information. Your consumers can get to that information quicker as well. So something to take into account, along with the counterpart, which is costs. And yeah, and you have to be very, very cognizant of how you throttle the data as you put it onto the stream. With one of our clients, we were actually doing this, and before we did the throttling, the Kinesis would just give you some errors. It wouldn't allow you once you exceed its quotas. So yeah, something to be very aware of. I'm going to talk a little bit about Kinesis Firehose and data analytics, but I'm going to focus mostly on data streams, is because it's what we've applied the most in our projects, and I believe it's along with analytics, data streams are probably the most complex ones. So a fire hose is basically it works as a real-time ETL. Unlike data streams, it doesn't have data storage. You can set the storage on the Kinesis stream for up to 1 week. So whatever you do with the fire hose has to be done live, and you will, if something errors out, you won't have recovery. You would probably want to add those manually as part of your infrastructure. It has another neat feature, which is you can, whoops, how do you go back? Okay, neat feature, which is you can put a Lambda if you want to do more complex transformations while the data is being fed live. And it integrates, Firehose also integrates very well with other AWS services. So for example, when you're setting up the Firehose and you want to land, you can land data directly with it to S3 buckets, Elasticsearch cluster, and many other services. But you set up what Kinesis stream or what sources it's going to get the data from. And you can set up for example, if you want to do Elasticsearch, you can set up the Elasticsearch instance, the index, and it does everything for you. So basically what it does is it makes it easier for you to get set up, but it gives at the expense of granularity. So if you want to do more complex things, you probably want to stay away from Firehose. Kinesis Analytics, it's really good for storing stuff into Redshift, for doing data transformations. It gives you really neat insights in real time in a sequential manner. So specifically very well suited for logging and for example, if you're working with your phone and you're continuously broadcasting your location, it's very good for analytics, especially for geolocation tools. And OpenSearch integrates and is really good working hand in hand with this. So this is going to be a use case of something we did in one of our projects. Of course, I've generalized it and made it in a way that we don't divulge client data, but for client information. So in a nutshell, and at a very high level, the goal was to move over 100 terabytes of entities to various places simultaneously. And the goal was to move this into a data processing via Lambda. We had an authoritative database, which is our RDS, and we had OpenSearch as a search layer. Large amounts of data required a very powerful search engine. One of the requirements was that we were able to do fuzzy searches, and the bigger your data sets, the longer your queries are going to take. It just comes with the territory. The existing setup when I arrived in the project looked something like this. This is one of the, so we had, as you can see, they were all validated. They had to extract the information from the buckets. We had to validate it. And then each Lambda would do its own thing. One would process, the other one would index to Elasticsearch. The other one would consume into an RDS. And you can see already from this diagram or from this illustration that there's replication of validation. Excuse the typos. But anyways, there's replication of steps. And so here are some of the challenges that we encountered. Validation of the same entity done multiple times. We had very tight coupling in this architecture, in which the bucket through a prefix alerted the lambdas. And this, the more things we attached to the bucket events, then we began to have prefix issues. So instead, we implemented an event bus. Anyways, we had lambda function timeout problems for very large files. Some of these files were over 500 megabytes, and lambdas were just timed out. Had to validate, parse, and then save or ingest or index. This was due to a lot of the replication of the processes, overhead, not to mention cloud costs that we were encountering. This was the proposed solution. Of course, there are other minor things that are not shown here, but in a nutshell, the validation was abstracted to a lambda that did it once. It read the files, so it had to read the files, parse them, validate them, and then it had to push the entity directly to the Kinesis stream. That's the beauty of Kinesis. You don't have to send event information. You can just push the entity already in there as a blob, as a stream, as anything you want. And so this would be pretty much a producer. This would be an event bus from an architecture standpoint. And these would be my consumers. So by taking the validation out of the consumers and the file reading, since they would consume the entity itself, we didn't have the timeouts were not an issue anymore. Validation was done in a single step. We had no replication of or overhead of logic. And we had shorter lambda times, of course, so benefits everywhere. And if down the line we decide we don't need any of these, either this process or this indexing or this ingestion to Aurora, then we just remove the consumer. It will not affect the rest of the architecture. Some of the conclusions from this is we have a single point of validation done in the producer. As spoken before, we end up with some loose coupling of processes. So it's ideal for event-driven architectures. No lambda timeouts. No need for reading, parsing, validating, just storing in the consumers. No bucket prefix issues. And you can gain valuable insights by analyzing data as it gets created, including what your business is doing right now. And this lowered our infrastructure costs. So does anyone have any questions you would like to ask about Kinesis?
Thank you, I think really nice. I have a question. You shown that Kinesis has three different flavors. And about the Kinesis Firehose. Okay. You said that you can process information before sending it to the targets, implementing Lambda functions inside the Firehose. Yes. Are you aware on the related costs to that? I mean, is the same to implement that inside Kinesis Firehose than implementing a standard stream and triggering a Lambda for the consumer?
I'm not sure about the costs, but what you should keep in mind when you're doing Firehose or streams is one has data, you can save the data for at least 24 hours, the other one doesn't. So it really depends on use case. That would be my main concern when using a Firehose against something else, is that your Firehose will not retain data. It would be, if something fails or dies, you lose it. So if you want to have retention, think streams rather than Firehose. And if you don't care about retention, then you can just think of a Firehose. And if the other neat thing about Firehose is that it's easy to integrate with your infrastructure. You don't need a lot of setup. You choose what you want to consume from, and you choose what you want to transmit to, and that's it.
Awesome.
Yeah, that's a good question. Anybody else? Going once, going twice? Well, I thank you all for listening. Make sure you like the video and make sure you subscribe to our channel if you haven't done so already. And have a wonderful weekend.
You too. Thank you.
Next time.
Bye, guys.
Yes.
Thank you. Bye.
Good weekend.
Bye.